All right, this is part 5. These next two are probably the trickiest ones that we're going to cover. So the action potential. It's a brief reversal of membrane potential with a total amplitude of 100 millivolts. So if here's minus 70, here is 0. If we have this action potential, this is going to be our action potential. We also know that the peak now has to be 30, right? So we have an amplitude of 100. So we're just going to start adding stuff to what we've already talked about in muscles. So, resting state, sodium and potassium channels are closed. We know positive on the outside, negative on the inside. More sodium outside, more potassium inside. And our sodium channel has 2 voltage regulated gates. This is something new that we're adding. We have an activation gate and an inactivation gate. The activation gate is closed and the inactivation gate is open. So we can take a look at this. Here is our activation gate. It's closed. Inactivation gate is open. So sodium can't get in. Potassium just has one gate that can't get out. So this is at the resting state, right? So we have minus 70. So depolarization, that sodium gates are opened and the potassium gates stay closed. The threshold, the critical level of depolarization is minus 50 or minus 55. That is the magic number that we have to reach. So if here is minus 70, we can put minus 50 here, 0. So we have to get to this spot. Once we get to this spot, the action potential will happen no matter what. So that is depolarization. Repolarization, the inactivation gates close and potassium gates open. So potassium exits, because think about it, after depolarization, right, at rest we had this. After depolarization, we have this from all the sodium. So now that the potassium gate's open, potassium rushes out. See the difference between what we had at the end plate potential with sodium and potassium moving at the same time to what we're talking about here is that sodium and potassium move at different times, but both end up following their electrochemical gradient. So potassium ends up leaving, and then we're back at this. So it restores the internal negativity. Hyperpolarization is because the potassium gates are slow, so more potassium leaves than has to. So that causes hyperpolarization. So after repolarization, we have the same resting electrical conditions. We don't have the same ionic conditions. That's going to be restored by the sodium-potassium pump. So let's take a look at this. At rest, and we have more sodium than potassium. Depolarization, sodium gates open, so now inside is positive. We have some sodium that entered, and we still have a lot of potassium inside. Repolarization, we are back, and we were at rest. The only difference is now we have some sodium inside, and we have some sodium outside. So the sodium-potassium gate covers that. Minus 70, minus 50, 0. This is 30. So here's depolarization. So here's our resting membrane potential. This is depolarization. The potassium gates open. Potassium rushes into the cell, getting more and more positive. Then they close. Potassium gates open. Potassium rushes out of the cell. The potassium gates are slow to close, so we have this hyperpolarization, right? It's going below 70. And then we get back up to 70, and that's from the sodium-potassium pump. And we see that here. I would try and focus on the blue line and disregard the yellow and the green. The blue line is kind of what I just drew. Okay, sodium gates open, so we have depolarization, and right at minus 55, this is where it becomes self-generating. It can't be stopped. So it opens, sodium gates close, right? Potassium gates open. That's repolarization. Hyperpolarization is because they're slow to close, and we go back to our resting membrane potential because of our sodium-potassium pump. Probably gonna have to review this a couple of times. I know it's a lot. Once you go through it a couple of times, I think you will get it. What I would try and do is start being able to draw this, okay, and then take a look at this graph and understand what's going on. Okay. All right, that's the end of this. Next one, we're going to talk about how it propagates.